What if you could go back in time to change a decision, or leap forward 1,000 years to see the future? Time travel has haunted human imagination for centuries, from H.G. Wells' writings to movies like Back to the Future and Interstellar. But the key question remains, what does science really say? Is time travel truly possible, or will it remain just a dream, forever out of reach? From ancient myths of gods who controlled time, to philosophers who wondered if fate could be changed, humanity has always treated time as more than just numbers on a clock. It's a mystery, maybe even a prison, but one we've always tried to escape. Traveling to the future. The astonishing truth is that traveling into the future is no longer science fiction. It's real science. Einstein proved it more than a century ago. Time is relative. When you move very fast, close to the speed of light, time flows slower for you than for everyone else. This means that if you traveled aboard a near-light-speed spaceship, you might experience days while years pass on Earth. And this isn't theory, it's been tested. In 1971, the Halfel-Keating experiment flew atomic clocks on airplanes. When the planes landed, the clocks disagreed with those on the ground, off by tiny fractions of a second. But in science, that tiny difference was monumental. It meant Einstein was right, time itself bends with speed. On the International Space Station, astronauts age microseconds less than we do here on Earth. Even your GPS wouldn't work if satellites didn't account for these time distortions. To make it clearer, imagine stepping into a spaceship that travels at 99.9% the speed of light. For you, 5 years pass, but when you return to Earth, 200 years have gone by. Nations have fallen, cities have changed. Your language might sound like ancient history. You would be a visitor in your own world. In other words, every satellite orbiting Earth is already a tiny time traveler. Traveling to the past. But traveling to the past, that's a different story. Relativity allows strange mathematical solutions, wormholes, shortcuts in the fabric of space-time that could connect not just distant places, but distant eras. The catch? To keep a wormhole open, you'd need exotic matter with negative energy, something that so far exists only in equations. And then come the paradoxes. What would happen if you prevented your grandparents from meeting? Would you still exist to take that journey? This is the classic grandfather paradox. Another is the predestination paradox. What if by trying to stop an event, you actually cause it? Imagine going back to stop a fire, only to realize your present started it. In this case, the past is unchangeable. You are part of it. And then there's the most mind-bending, the bootstrap paradox. What if you went back in time with a book, gave it to a younger version of yourself, and that book is the one you later bring back? Where did it come from originally? A loop with no beginning, no end. A paradox without an origin. Here, science collides with philosophy. Is the past truly changeable, or is it carved in stone? Alternative theories. To solve these paradoxes, some scientists suggest another answer: parallel universes. Each time you travel to the past and change something, you wouldn't alter your timeline. You'd create a new one, an alternate universe where events unfold differently. The past isn't erased, it branches. Quantum physics, with its principle of superposition, fuels this idea. Multiple realities coexisting at once. In this vision, time travel is also universe travel, but not everyone agreed. Stephen Hawking defended the chronology protection conjecture, that the universe itself would prevent travel into the past, almost like a cosmic guardian protecting the timeline from being altered. And yet, others suggest black holes may hide bridges in time. Inside their crushing gravity, equations hint at wormhole tunnels, invisible shortcuts through space and time. The danger? No one knows if a traveler or even light itself could survive the journey. On paper, traveling to the past isn't forbidden. The question is, what would nature choose? Culture and fiction. Time travel isn't just physics, it's culture. From H.G. Wells' The Time Machine to Doctor Who, from Terminator to Interstellar, every generation has reimagined the rules of time. Sometimes it's a warning about changing history. Other times it's about destiny, hope, or the fear of fate. Perhaps our obsession with time travel isn't about science at all, but about a deep human desire, the wish to undo mistakes or to see what lies ahead. Scientific attempts to test time travel. Time travel isn't just theory. Scientists have actually tried to test it. In 2009, Stephen Hawking held a time traveler's party. He sent the invitations only after the event, reasoning that if time travel was real, guests from the future would show up. No one came, at least not yet. Physicists have also searched the internet for evidence of time travelers, looking for posts, tweets, or messages that mention future events before they happen. Again, nothing was found. And in particle physics, experiments with neutrinos and quantum entanglement sometimes raise the question of whether information itself could move backward in time. So far, the answer is no. But every test, even the failures, shows one thing. Humanity refuses to give up the search. We keep asking the same question. Is time travel impossible, or are we just not clever enough yet? What we know today. So, what do we truly know today? First, traveling to the future is real, though only on the tiniest scales. Astronauts, satellites, and atomic clocks already prove it daily. Second, traveling to the past remains an enigma. Equations allow it, but paradoxes and technical barriers make it nearly impossible. And third, the mere idea that time may not be linear changes everything. Perhaps time isn't a river flowing in one direction, but an ocean, full of hidden currents, whirlpools, and unseen paths. Maybe time is less like a line and more like a library. Each page, each chapter already exists, but we can only read one at a time. The rest of the story waits, silent, invisible, but real. Closing reflection. Maybe we'll never stand among the dinosaurs, nor glimpse what humanity looks like 1,000 years from now. But in one sense, all of us are already time travelers. Every time we look at the night sky, we are seeing the past. The light of those stars left thousands, even millions of years ago. What we see is not the present, it's the cosmic past. The entire universe is a museum of time. Every galaxy, every star, every supernova speaks to us from another age. And in a way, we're all travelers through time, bound to a single direction. And maybe that's the real mystery. Time travel isn't only about machines or equations. It's about understanding our place in the universe. Every second we live is a step into the unknown. So the ultimate question remains, if you had the chance to travel through time, would you choose the past or the future? Perhaps that choice is less important than the mystery itself, because some secrets are still waiting to be revealed. See you in the next video.